This is Unit 2, Section 1. We are covering piecewise functions, Day 2. So today we're going to talk about how to graph a piecewise function. So our first step is we're going to draw vertical dashed lines where the boundaries and the domains occur. So we are going to have something like x is less than or equal to 0 and x is greater than 0 as our two domains. So on our graph at x is 0, we would draw a dashed line, and that's where we're going to separate our graphs. For each function, we're going to create a table of values starting at the point on the boundary, so we would be starting with 0 in this case, and then using two other points that fit that inequality. So for less than 0, I would use -1 and -2. For greater than 0, I would use 1 and 2. We'll graph each of the lines connecting using these points, and we're going to determine open or closed circles along the boundary line points. So it would have been closed here, and it would have been open here. So let's do one. We have x is greater than 2 and x is less than or equal to 2 as our two domains in this problem. So I'm going to go over to x is 2 and I'm going to draw my dashed line to separate my two lines. Now for both of them I'm going to plug in 2. So 2 goes here and 2 goes here. Since this is x is greater than 2, I'm going to pick other numbers that are bigger than 2 to complete my problem. So I could choose 3 and 4. For less than or equal to 2, I'm going to pick numbers that are smaller than 2. So I could pick 1 and 0. Greater than did not have the equal sign, so that is going to be a open circle. And this one, the 2 did have the or equals, so that's going to be a closed circle. So now I'm going to substitute in 2 to this equation. So we're going to have 2 plus 2, and we get 4. I'll plug in 3 to this equation, so we have 3 plus 2, or 5. And then I'll plug in 4 to that equation, so we have 4 plus 2, or 6. So I could already graph this line. I have the point 2, 4 with an open circle. I have 3, 5 with a closed circle. And I have 4, 6 with a closed circle. So this line's going to look something like that. Then I can go to my other half. Now I'm going to be plugging them into the less than or equal to 2 part. So that's going to be 2 times 2 plus 2, or 4 plus 2 is 6. 2 times 1 plus 2, so that's 2 plus 2, or 4. And then 2 times 0 plus 2, or 0 plus 2 is 2. So I'm going to graph the point 2, comma 1, 2, 3, 4, 5, 6, and that's a closed circle. I'm going to graph the point 1, 4, and I'm going to graph the point 0, 2. I'm always going to start at the one on the boundary line and then continue the other way. So that would look like that. Right? I don't want any points of this line going past that, and I don't want any points of this line going past that. Let's try another one together. So now I have x is less than or equal to 0 and x is greater than 0. So 0 is going to be my boundary line. And that means 0 is going to be in both of those. This one had or equal to, so that one's going to be closed. This one had no or equal to, so this one's going to be open. So now I'll start to plug some stuff in. So we have 0 plus 4. I'm doing things less than 0, so -1 and -2. So 0 plus 4 is 4. -1 plus 4 is 3. -2 plus 4 is 2. For the other graph, I want numbers bigger than 0, so I'll choose +1 and +2, and we're plugging into this equation. So 2 times 0 plus 4 is 0 plus 4. 2 times 1 plus 4 is 2 plus 4, or 6. 2 times 2 plus 4, or 4 plus 4, oops, is 8. I can graph each of these now. So I have the point 0, 4, and that's closed. I have negative 1, 3, and negative 2, 2. So there's one line. For my other one, I have 0, 4 again, and it's open. I'm just going to show open around it. That's fine. Then I have 1, 6, and 2, 8. All right, so the graphs can overlap each other. That's fine. If we were looking at this picture, we would not have known which one had the or equal to, and it wouldn't really matter which one had the or equal to in this one because the point is already included. So you go ahead and try this one. You can pause it, and I'm going to show the answer. All right, so that's what your graph should look like. It almost looks like an absolute value graph, which we'll be talking about soon in class. So now we have a three-part function. So we're going to have a boundary at negative 1, we're going to have a boundary at positive 2, and that means we're going to have one function on the left side of the graph, one between the negative 1 and the 2, and one at the 2. So for the negative 1, I'm looking at less than or equal to negative 1, so that'd be negative 2 and negative 3, and that's going to be a closed circle. I'm going to jump over here to this one, the 2, and I'm looking for numbers bigger than 2. So I could choose 3 and 4, and that's going to be an open circle. The one in the middle, I need to make sure I include the negative 1 and the 2. And then I could pick anything that happens between them. 0 is always the easiest to plug in. So on the negative 1, that's going to be open, and on the positive 2, that's going to be closed. All right, so we can plug in for each of these now. So my first equation, x plus 4, so we have negative 1 plus 4, we have negative 2 plus 4, and negative 3 plus 4. All right, then we have 3x. So 3 times negative 1 is negative 3, 3 times 0 is 0, and 3 times 2 is 6. And then I have 1/2 x squared. So it's going to be 1/2 times 2 squared, so 1/2 of 4 is 2. 1/2 of 3 squared, so 1/2 of 9 is 4.5. And 1/2 of 4 squared, so 4 squared is 16, half of 16 is 8. So these are the points we're going to use. So here's our graph. So I know I'm going to put my boundaries at negative 1 and at 2. Now I can graph my blue line at -1, 3 with a closed circle, -2, 2, and -3, 1. So that's going to go like that. The one in the middle is going to have an open circle on -1, -3, and a closed circle on 2, 1, 2, 3, 4, 5, 6. And we know it should be going through 0, 0. So it's going to look like that. And then our last line, open circle on 2, 2. Then we have the point 3, 4.5, and 4, 8. And that would be our piecewise function for this one. So you can go ahead and try both of these, pause it, and I'll show the answer. All right, guys, so check your answers. Notice this last line is a constant. It was just 2, so all the y values were 2, regardless of what the x values were. And for 1, I chose to put in multiples of 3 because I had the 2/3, just so I didn't have to deal with fractions. You don't have to, but if you recognize that putting in a number that's multiple of 3 would get rid of the denominator, you can do that. And that is this lesson.